This is the exponential parent function. The equation of this function is f of x is equal to some number, we'll call it b as in base, to the power x. This number b can be any positive number except for 1. For sake of getting a nice picture, I want to put in a number for b. So I'm going to pick a number that satisfies these two conditions. So it has to be larger than 0 and not equal to 1. So the number I'm going to pick is 2, because it's a nice, easy number to work with. So we'll be graphing this one. F of x equals 2 to the power x. In order to figure out what the picture looks like, I'm going to select some x values and then substitute them in to calculate for the y. So I'm going to start with -1, 0, 1, and 2. If I put a -1 in place of the x, this would say that the y is equal to 2 to the power -1. Now, 2 to the power -1, a -1 power actually means you take the reciprocal of whatever the base is, and then raise it to that positive power. So 2 to the -1 actually means 1 over 2 to the power 1. So 1 over 2 to the power 1 is just 1/2. If I put in 0 in place of x, then this would say the y is equal to 2 to the power 0. And we know that 2 to the power 0 is 1, because any base raised to the power 0 is 1. If I put in 1 in place of x, this would say y is equal to 2 to the power 1. The 2 to the power 1, that would just be a 2. Anything to the power 1 is just itself. I put in 2 in place of the power. So this would say y equals 2 to the power 2. 2 to the second power means 2 times itself, 2 times 2. So that would be a 4. We'll go ahead and plot these points and see if we can figure out what the graph looks like. So -1, 1/2, start at the origin. That means we go to the left 1 and up 1/2. 0, 1, start at the origin, go over 0 and up 1. 1, 2, so start at the origin, go to the right 1 and up 2. And then 2, 4, start at the origin, go to the right 2 and up 4. So far it looks a little interesting, but I'm not convinced that I know what's going on here. So I'm going to select another x value. I want to know what's happening over on this side right now. So I'm going to pick -2. If I put -2 in place of the x in the equation, it would say that the y is equal to 2 to the power -2. As I mentioned before, a negative power means you just take the reciprocal of whatever the base is. So the reciprocal of 2 is 1/2, and then raise that to that positive power. So that would be 1/2 to the second power, which means 1/2 times 1/2, which is 1/4. So this point would be -2 1/4. We'll go ahead and plot that and see if we get an idea about what's happening. So start at the origin, go to the left 2, and up 1/4. It appears that as I move further to the left, the y values are getting closer and closer to the x-axis. Just to be sure, I'm going to pick a number that's a little bit bigger and just think about it. I'm not actually going to plot the point. But if I picked, say, maybe -6, and I put that in place of x, then this would say that the y is equal to 2 to the power -6. So again, negative power means I take the reciprocal of the base, so that would be 1/2 to the power +6. So that means I'd have to multiply 1/2 times itself 6 times. So 1/2 times 1/2 is 1/4, times another 1/2 would be 1/8, times another 1/2 would be 1/16, times another 1/2 would be 1/32, and times another 1/2 would be 1/64. So that's a tiny, tiny little fraction, 1/64. So that means out at -6, it would still be above the x-axis. The y value would still be above the x-axis, but very, very close to the x-axis, very close to 0. So as I move out this direction, it looks like the values are getting closer and closer to 0, which lets me know that there's an asymptote going on there. This graph is getting close to that value. So there's actually an asymptote here, horizontal asymptote. The equation of that asymptote is y equals 0. Now as I look to the right of this on this graph, it looks like the y values are increasing. So just to be sure that I know what's happening, I'm going to pick another one, like say 3. If I put in 3 in place of x, this would say y is equal to 2 to the power 3. So that would mean 2 times itself 3 times. So that would be 2 times 2 is 4, times another 2 is 8. So at 2, it would be 8, so it would be way up here somewhere. And if I chose 4, then 2 to the 4th would be 16, way up there. So it's increasing very rapidly over here. So when I draw in this side of the graph, I want to make sure that I indicate that it is increasing very rapidly. Now it looks like there might be an asymptote going on over here, so I need to think about that a little bit. Is there a limit to the x value that I could choose? Like if I pick an x value over here, something bigger than what I can see so far, and we thought about 3 and 4 already, so something bigger than 4, and I put it in here, would it give me something that is undefined? I can see there's really not. I could pick numbers larger and larger and larger for x, and the y value would just continue getting larger and larger. So there is no boundary over here to block it off, make the graph no longer include those x values. So that kind of brings us into the domain. The domain is, of course, all of the x values for the graph, so they would be all the x values that are allowed for this function. Now we just discussed we could put in negative numbers, we could put in positive numbers, we could even put in fractions and everything. So that means the x can be any real number. The y's, on the other hand, since we're always taking 2 and raising it to a power, and anytime you take 2 and you raise it to a power, you get a positive value, the y values, or the range, is going to include only positive numbers. So this would be y is greater than 0. And that's strictly greater than 0, not equal to. Intervals of increasing, decreasing, and constant. So I'm going to move my pen across the graph, starting at the far left as I can see. And as I move toward the right, my pen is actually moving upward just a tiny little bit with each time I move to the right a little bit. And when it's moving upward, of course, we know that that means that the graph is increasing. The function is increasing on that interval. So that was as far left as I could see. And it would continue doing that as far right as I could possibly go as well. So that would be on the interval of x's from a negative infinity to a positive infinity. And I'll put that in parentheses to indicate that it is an interval from this value to that one. Now this interval is actually the same as the entire domain. So that means this function is increasing on its entire domain, which means it can never be decreasing, and it's never constant. What you need to know about this function is its name, exponential. The equation, f of x is equal to b to the power x, and you need to know that b must be positive and not equal to 1. You need to know what the graph looks like, and you need to know that it has a horizontal asymptote at y equals 0. You need to know the domain and the range.